Hello, I'm BPK Godanda Vidyaman. I'm going to talk about multiple HVDC system. Multiple terminal HVDC system. This type of HVDC configuration uses multiple transmission line to connect more than 2 points. These are multiple terminal station with their own converter connected by the HVDC transmission line network. Some of these converter operate as a rectifier while other acts as an inverter. The power supplied by the rectifiers combination is equal to the combined power received by the inverter stations. This is a type of multiple terminal DC system. This type of DC network is equivalent to the AC grid that is flexible, but it has the capability to control the power flow in the DC distributed network. Such type of network is much more complex than a two-terminal HVDC configuration. In a multiple DC system, we cannot use the AC circuit breaker on the AC side because it will degenerate the whole DC network instead of isolating the specific line having fault or a scheduled maintenance. Therefore, MTDC system require multiple DC switch gears that can safely de-energize the circuit or isolate it in case of a maintenance work or a fault clearance. It is also required to balance the system in such a way that the amount of current supplied by the rectifier station is equal to the amount of current in the inverter station. In case of a high demand of power from any inverter station, the DC power is ramped up to meet the requirement. It is necessary to monitor and control the voltage supplied as well as the inverter in case of overloading. The MTDC systems are reliable in case of forced outage, that is unexpected power failure from one of many generation status. The power supply is relocated through another converter station. There are two types in a MTDC system. There is series and a parallel. We'll see about series MTDC system. In such configuration, multiple converter stations are connected in a series with one another. Just like in a series circuit, the current flowing through through each of the converter station remains the same, which is set one station will the voltage drop may divide among the converter stations. This system usually uses monopolar DC links wherein the line is grounded at the one point. However, a grounding capacitor can be used at any other line for protection against transients. In a series MTDC system, the power flow reversal can be easily implemented using both voltage source converter and current source converter. The power flow is parallel in MTDC system is a little complex as compared to the parallel MTDC system because a parallel MTDC system cannot control its power flow by injecting current in a specific line, while in a series MTDC system the power flow control is done by voltage control at each terminal station. In case of a fault or a scheduled maintenance in a specific line, the whole DC network will face a blackout. Therefore, just like a two-terminal system, the circuit breaker on the AC sides is used to de-energize the DC network. The same is the case with the expansion of the series MTDC system. It is also quite difficult and requires the whole network to face blackout during the installation of a new terminal station. In order to install new terminal station, the DC network must be split up at the point of installation, which will break the supply to every other station of the path. Let's see about the parallel MTDC system. In a parallel MTDC system, there are multiple converters or a load station that are converted to a single converter station. These converter acts as a rectifier that supply power to the whole DC network. Just like a parallel circuit, the voltage remains constant or the same at all the inverter or a load station that is set by one of the converter station, while the current supply may changes depending on the power demand. According to the power demand at each load station, the current is adjusted to balance the current supply. These terminal stations generally of higher capacity than in a series network. This is a parallel multi-DC system. In a parallel MTDC system, the voltage reversal using a current circuit based terminal station affects all converter station. Thus we need to implement a sophisticated control and communication system between these converter. However, if the power reversal is done using the current reversal technique using voltage source controller based terminal station, it will be much easier to realize. It is the reason the voltage source converter are preferred in parallel in a multiple DC system instead of a current source converter. Since the voltage remains constant in the voltage source converter, The current rating of the valve converter decide the power rating of the terminal station. It offers a wide range of power flow control in the DC network by injecting current in the specified range. This is more convenient than the power control in a series system using voltage control at each station. The best feature of the parallel MTDC system is that if there is any fault in any terminal station, the remaining DC network will not get affected. But we should isolate these specific DC lines. It does not need a separate DC circuit breaker. Also, in case of expansion of DC network, the power supply does not need any interrupted. It will not be interrupted because the new terminal installed is in parallel from the existing lines. The insulation coordination in such a system is far more simple than in a series system because the voltage remains always constant. Okay, radial MTDC system. The radial MTDC system is a type of parallel multiple terminal DC system configuration where a break in a transmission line or removal of one link will cause interruption of power supply to one or more than a converter station. This figure shows 4 inverter stations connected with a single rectifier station. Break in one of these lines will surely interrupt the power supply to minimum of our one terminal station. Because of such interruption in power supply, they are unreliable or as compared to mesh or ring type MTDC system. Mesh or a ring MTDC system. In a mesh or a ring MTDC system, the inverter load stations are connected with a single rectifier station in a mesh or a ring formation where a break in one transmission line or a removal of one link does not interrupt the power supply to the inverting station. This figure shows the parallel connected mesh type multiple terminal DC system. It have a rectifier station connected to inverter station connected in a mesh. The inverter station also connected. There will be three inverter station connected and a rectifier station in a mesh type connection. As you see, the removal of any link will not interrupt the power supply to any converter. But here in a radial MTDC, if any one link is removed, it will cause interrupt. But in a ring type, there will be if any interruption, the power supply will not be interrupted. In fact, the power will be routed through the other links. However, the other link must be designed to withstand the power transmission with power losses. There is no more power interruption in a mesh type MTDC multiple terminal DC system. Therefore, parallelly connected mesh type multiple terminal DC system is more reliable than a parallel connected radial type MTDC system. Application of MTDC system. This multiple terminal DC system connects multiple DC renewable energy farms to multiple power grids. Connecting multiple offshore wind farms to the power grid. This can transfer bulk power from a multiple remote AC generating station to a multiple load centers. Allow interconnection between the two asynchronous AC power system. The power supply reallocation in a case of power failure in one of the generating stations. It can be used to offer more to a heavily loaded AC network by using one rectifier and multiple inverters that inject power into the said AC network. Offers flexibility for power tapping at multiple points. Thank you.